All right, hopefully I'll get through this, my third video, with the law of sines and law of cosines. Still in section 1, by the way. Okay, so we still have oblique triangle, so it's a non-right triangle. We can still use the law of sines. We can still use sines. So let's say I asked you to figure out what h is, only looking at the left triangle. Well, we just did this in the previous video, that we could set up a trig function that says sine of c is equal to h over b. Well, then we can solve for h by multiplying the b over. So that should be familiar to you. Well, let's look at the other one, the other right triangle, which is over here. We can do sine of b, let me write over here, capital B, which equals h over lowercase c. Well, now we can solve for h by multiplying the c over, so c times sine of b is equal to h as well. Okay, well, lo and behold, they both equal h. So that means that these two things must equal each other as well. So b times sine of c must equal c times sine of b. Now, I don't know why, but somewhere along the line, somebody said, well, what if we just divide something over? You know, like divide c to the left side. That's a capital C, by the way. Poorly written, but sine of capital C, because we always do sine of an angle over lowercase c. So sine of an angle over the side length across from it must be equal to sine of the angle divided by, divide this b over the side across from it. And what you'll also notice is if this is true, then it also must be true that sine of a over the side length a must be equal to it. So this is acceptable. Or the law of sine, sometimes we write it the other way, like a over sine of a equals b over sine of b, which equals c over sine of c. So as we look at an example, and by the way, it's kind of uniform. I shouldn't just assume. I should draw this a little bit better, though, because this is clearly an obtuse angle. If I had an obtuse angle B, it's universal that side length C, 11 centimeters, is across from angle C. So this is angle A, 130 degrees here. And then side length B is across from angle B. So the whole premise of this is first you want to figure out, like, set up some sort of equation where you have only one unknown. So if I were setting it up the way I just wrote it, 15 over sine of 130, because those are the two that are across from each other, my other unknown would be 11 over sine of C in degrees. So you can cross multiply. This is how I do the problem. You don't have to do it my way, because some of you might find a faster way. Is equal to 11 times sine of 130 degrees. And then divide the 15 over. And let's do two steps at once, because C in degrees. If you're ever solving for an angle, you need to do the inverse sine of 11 times sine of 130 all over 15 inside those parentheses. So how do you type that into your calculator? Again, make sure you're in the right mode. I haven't changed the mode because I've been teaching this unit all in conjunction. So make sure you do that. Inverse sine, my calculator, if you just hit alpha x, it makes a fraction. Some other calculators, I don't know if you know this, you might have to hit alpha y equals, and then you can make the fraction. I don't know how your calculators work, but it'd be 11 sine of 130 over 15. Let me just double check I wrote that correctly. 11 sine of 130 divided by 15. I don't think you have to close a parenthesis, but you might as well. Hit enter, and it'll give you the correct answer of 34.178 degrees. Measure of angle C is equal to, I already forgot what it was, 34. Man, why I'm gonna start writing 1. Degrees. Perfect. Okay. Now, here's the one time that I'm not going to heed my own advice. Is in order to figure out angle A, you have to use the approximate number here. So earlier when I said never use an approximate value, you have to on this one because there's no other way to find angle A. Well, angle A would be 180 minus 130, because remember the three angles have to add up to be 180. Minus 34.178. So 180 minus 130. If he had second the negative sign, you don't have to copy that down. 15.822. That's the measure of angle A. I'm trying to fit this all on one screen so I don't have to go up and down. Now here's where, again, it would be to your benefit to use the information that is not rounded. Like neither the 15 or the sine of 130 is rounded. So you would want to use that to figure out side length A and the angle you just found. And what's nice too is if you leave this saved in your calculator, and you use sine of the answer, you're going to get the best answer. Okay, I wish we had in-person classes so I could really hammer this home. So hit sine of the answer. And all I'm going to do is cross multiply and divide. So times 15 and divide by sine of 130. Times 15 divided by sine of 130. And you get about 5.339. Units are nice, but they're not 100% necessary. And my answer makes sense. The smallest angle is by far across from the smallest side. The largest side is across from the largest angle. Your answer should make sense. I really shouldn't put a box around this thing though, because that's not a final answer. But I was trying to show you how to set this up. So my boxed-in answers should be good. All right, and we have one more item to discuss. I'm going to go to the answer key because I always struggle through this next one. Is the law of sines only applies at certain times. The law of sines applies when you have three side links. Because if you have, I said that wrong. If you have three side links, that's not enough information to be able to find the three angles. The law of sines only works if you have two angles in one side or two sides and one angle. So I said this wrong. I actually should go back and re-record myself. The law of sines will not work if you have three side links. It also does not work if you have three angles. There's no way to figure out the sides if you only know the angles for the law of sines. And it will not work either for side angle side. So we must have a different method of doing the law of sines. And that's where the law of cosines comes into play. This formula right here. Now, I know it looks like a lot, but again, as we move forward, at least while we're virtual, everything's take-home, so it's not like you have to memorize this. But notice that this formula works to find a side length when you're given the two side lengths and the included angle. So a squared is equal to b squared plus c squared minus 2bc cosine of a. That's why it's called the law of cosines. And if you're interested, feel free to ask me. I can explain why this formula works. It's just the videos, they're already on our third video. So go ahead and pause this and write down. You only need to know one of these because the other two follow exactly from it. You know, if it's b squared, then it's a squared plus c squared minus 2ac cosine of b. So notice that that's the only thing that changes. So let me get through at least one of these examples. We'll see what happens. So if we're given the three side lengths, maybe you just want to find cosine first. I would encourage you to start with the biggest. Do the biggest first. There's a reason for that. But just heed my advice right now. So what I'm saying is I want to do the 9 squared, which is equal to, it doesn't actually matter because addition's commutative. And I'm just making sure I'm doing this right. A squared plus c squared minus 2 times 4 times 6 times cosine of angle C. Now, I've actually seen people, and I'm all for this, is they actually memorize a slightly different formula for the law of cosines, and you can Google this. Again, my video is kind of long as it is. Because what they do is they think about, oh, well, I can solve this by subtracting 4 squared over, subtracting 6 squared over, and then dividing by negative 2 times 4 times 6. And I forgot to do one more thing. Let me really highlight it for you. If you're ever answering an angle, you have to do the inverse trig function that you're doing. So as you go to a calculator, you can just type it in like that. Inverse cosine, make it a fraction, of 9 squared minus 4 squared minus 6 squared over negative 2 times 4 times 6. Just double checking I typed that in perfectly. And you should get the right answer. This is why I would encourage you to start with the biggest angle, because it will give you an obtuse angle, 127.169. And for the sake of time, I'm going to encourage you to just do the same thing with B and C. I thought I changed colors. Because if you're solving for B, you just got to switch things around. You know, instead of 9 being here, then the 4 goes there. And just swap things around. And instead of a 4 going here, it's a 9. And I'm going to go to the answer key. And you can see that the answer, we figured out 127.169, and it would just be more practice of going to the calculator and typing these in. And example B on this side is actually just following the formula. And the biggest mistake I've seen is students forget to square root at the end. That's the biggest thing. If it helps, definitely draw out the picture. But as I mentioned before, it's universal that angle A is across from side length A, angle B is across from side length B, and angle C is across from side length C. So that might help you visualize. And notice on this problem, if you want, you can switch over to the law of sines once you have enough information. You can even switch over to knowing that the 3 angles have to add up to be 180 and start subtracting off. The only downside, you might want to listen closely, is the law of sines does not find obtuse angles. So let me write that down. Whoa, I don't know what I just did. I zoomed in. So you might want to pause the video, write down the correct answer. You can even pause and try it on your own. Make sure you can get the right answer. But let me give you a warning. Warnings need to be large. Law of sines does not find obtuse angles. The law of cosines will. That's why I said to do the biggest first for the law of cosines. Because if you do the smallest first, and then you try to do the law of sines later, you might get the wrong answer. So that is a big warning. Start with the biggest with the law of cosines. And you should be ready for the homework.